subscribe to my channel, and also press this bell icon.
Okay, how to solve this potentiometer problem in just three minutes. Okay, I will explain in 3 minutes, but you can solve in only 1 minute, less than 1 minute. Okay, so how are you going to solve? This is a potentiometer. Balancing length is given, that is 1200 centimeters, whereas this is called as a primary circuit. This is called as primary circuit. This is called as secondary circuit. Okay, so balancing length is given as 1200 centimeters, complete wire from here to here, whereas the other here an EMF is considered 5 volts, and this is connected to series resistance 20 ohms, which is connected to galvanometer. What is the current flowing through this? It is also given in the diagram. The current flowing in this is going to be 60 milliamperes, and total length or net length is how much? It is going to be 1200 centimeters, which is considered to be capital L. And balancing length, what is the balancing length here? If you observe the balancing length small l, it is going to be 1000 centimeters, it is given here. Okay, then if he has given the EMF of a smaller cell which is considered to be 5 volts, then what is the potential across here? What is the potential across the primary cell? How are you going to find out the potential across the primary cell? You know that what is potential gradient? You know potential gradient is given by x, which is V by L here. Okay, and potential gradient is going to be constant. From this you will understand that V is directly proportional to L here, because from here you will understand that V is equal to XL. So V is directly proportional to L. Then what happens? Vp by 5 volts here, Vp by 5 volts is equal to, Vp means primary cell, so primary length, total length is considered to be 1200 here, and the EMF of a cell, if you consider as 5 volts, potential difference is 5 volts, then what is this length, balancing length, you have to consider here, that is 1000. So this is going to be cancelled here. Then this is 5 ones, 5 twos, so 2 ones, 2 6. So therefore we got the balancing potential of the primary cell is going to be how much? 6 volts. But if you observe here, balancing length is given, EMF is also given, internal resistance is also given, and he's asking us to find out what is the resistance of the potentiometer wire. So you need to find out the resistance of this potentiometer wire. What is the resistance of this potentiometer wire? How are you going to find out the potential? So resistance of the potentiometer is equal to voltage of the potentiometer by current across the potentiometer. So what is the voltage across the potentiometer? Try to see here. Try to observe. Potential across the potentiometer, just now we got it as 6 volts. Okay. And what is the current across the potentiometer? It is given as 60 milliamperes. So 60 milliamperes is given here. Then 60 milli means 10 power minus 3. If you observe it, 10 power minus 3 goes to numerator here. Okay, so you are going to get how much? Let us see. So how much you are going to get here? So if you observe here, 6 will be like that only. This 3 comes to the numerator, becomes 10 power 3 divided by 60. So this 0 gets cancelled here. So 10 square is left, 6 gets cancelled here. So 10 square is left, that is answer is going to be 100 ohms. Okay, so this is going to be your answer, that is 100 ohms. So he's asking us to find out what is the resistance of the potentiometer wire, and this resistance of the potentiometer wire is going to be 100 ohms. So it's a very simple problem here. Okay, so it's a shortcut formula. Only you have to consider potential is equal to XL, that's it. Okay, potential gradient is equal to potential per unit length, and V is equal to XL. This is a previous year question, 2020 Z mains question asked in the month of January. Okay, thank you very much. It's a very simple answer.